mathematics. Mathematics first starts when we objectively perceive the real world with the five senses. All right, so when we see, okay, when we smell, when we hear, all right, when we taste and when we feel, all right, we perceive our surroundings with these five senses. Then what we do, we subjectively abstract a mental image, all right, formed in the visual cortex and other areas of the brain. And we do that using words. And then we convert those words now to diagrams and symbols, okay, to facilitate the documentation, thus written communication of ideas involving numerical analysis. Okay, so that's what first happens. We perceive the environment, and then now we abstract from that mental image a lot of symbols, okay, and we use that symbols now to symbolic language to communicate our ideas. All right, that involves computation, that involves numerical analysis. Okay, so here we have Isaac Newton. Okay, and as the story goes, he sat on the tree and he, you know, apple fell. Someone say, well, according to this diagram, that it fell on his head, but I'm not too sure it fell on his head, but it fell, and then he observed, he perceived, he saw it, right? He probably heard the thump, and from that now he was able to extract this that equation and other equations. So that's just one of them, okay, that came out from that observation of that phenomenon of the apple, okay? S is equal to ut plus half at squared. All right, this is the formula for displacement under the force of acceleration, under force which has acceleration, and also, you know, and S now stands for space, or for spatium in Latin. Spatium is space in Latin, so that's why you have S for displacement, distance move, and U for initial velocity, T for time, and A for acceleration. Okay, U, because U comes before V, U is for initial velocity, V for final velocity. So therefore you have words, and then words converted to symbol. Spatium, space, S. Initial velocity, U. Time, T. A, acceleration. And normally what happens now, the mathematicians normally use the first letter of the word to create the symbol. Okay, the equal sign has its history also. The plus sign has its history. Okay, how it came about, how the plus sign came about. The plus sign is the symbolic language for and. Okay, and in Latin is et, and the T here comes from the et from it in Latin, because it is and in Latin, and a plus now is used to represent and. Okay, so that's what basically happens. So it always begins with the real, and then you have words, and then you have symbols. Here you have Albert Einstein. The same thing happened. Okay, he perceived a light beam from a clock and imagining on the light beam, and then what he intuit from that is that if you happen to travel the speed of light, time will actually stop for you. Okay, so from that he was able to deduce that very famous formula for in the theory of relativity, whereby time is different for different observers, meaning that if you are in motion, your time slows down. If you have to travel at the speed of light, your time will actually stop for you. If an observer is watching you, the time is different from your time. Okay, it says time measured from an observer outside the frame of reference is equal to the time measured from an observer is different. All right, or is equal to the time. There are two times that are different, T and T sub 0. T is for the time of the observer outside the frame of reference, and T sub 0 is for the time for the person, for the observer in the reference frame. So the time measured from an observer outside the reference frame is equal to the time measured from an observer inside the reference frame divided by the square root of 1 minus the speed of the reference frame divided by the squared divided by the speed of the light squared. Okay, so you have T sub 0, 1 divided by the square root of 1 minus V squared over C squared. And as you can see, V squared over C squared will always be a decimal. 1 minus a decimal will be a decimal. The square root of a decimal is a decimal. T sub 0 divided by a decimal will give you a greater number than T sub 0 itself. So the T of the observer outside the reference frame will always be greater than the T of the observer inside the reference frame. Here again, you have the same formula transposed to make T sub 0 the subject of the formula. And according to this now, you can interpret that the time of the observer inside the reference frame that is moving, that's T sub 0, is always less than that of the observer outside, all right, of the reference frame by a factor of 1 minus v squared over t over c squared. All right, so therefore now from that you can actually deduce that t sub 0, okay, t sub 0, t sub 0, that is the time for the observer inside the reference frame, okay, time for observer inside the reference frame, okay, time inside reference frame, t inside reference frame, all right, okay, that's t sub 0, will always be less, okay, than the time outside the reference frame, okay, according to Albert Einstein. So this is what this equation is basically saying. Okay, the time inside the reference frame is actually less than the time outside the reference frame. So therefore now, different observers have different times according to what Einstein is saying. Albert Einstein is saying something different from Isaac Newton. Isaac Newton is saying time is constant, but here Albert Einstein is saying time is different for different observers. Okay, and the whole idea is that they both started from what was observed, and from that abstract information was deduced. Okay.